Hello students. So today we will start with series AC circuits. In previous lectures I have told you about a circuit having only resistor, only inductor and only capacitor. Now we have to combine two elements and we will go with initially with series RL circuit, then series RC circuit, then RLC series circuit. So today I will start with series RL circuit. Series AC circuit. First is RL series circuit. Clear? So what will be the circuit diagram? Here one resistor will be there and one inductor will be there. Here we are providing a single phase AC supply V equal to Vm sine omega t. All these calculations and concepts are related to single phase AC circuits. Now this is R and this is L. Voltage drop across R will be VR and voltage drop across L will be VL. Clear? So what will be the value of VR? VR will be equal to I into R, and it is series circuit, so current will be same in the resistor and inductor. And what will be the value of VL? VL will be equal to I into XL, where XL is equal to what? Omega L, and omega is equal to 2 pi F, so XL will be equal to 2 pi FL. Let us draw a phasor diagram for this circuit. So as we have learned previously that in case of resistor, the current will be in the same phase of voltage. So in series circuit current will remain same. So I will take a current as a reference phasor. So this will be the voltage across R in the same phase of current, and the voltage across inductor will be 90 degree ahead the current. So here I can draw the VL voltage. Clear? So this is VR and this is VL. So phasor sum will be V. V will be equal to under root VR square plus VL square. This is the voltage that we have applied. Similarly, we can convert this triangle into impedance triangle, because we are having VR equal to I into R and VL equal to I into XL and V will be equal to I into Z. So on removing I, we can draw that this will be R and this will be XL, and the combined phasor diagram will be Z. So Z will be equal to R square plus XL square, or in phasor form you can write rectangular form R plus J XL. So this will be the expression of impedance. This Z is called as impedance for the circuit. Clear? So from here, if I will draw only current and voltage, this will be the current and this is the total voltage V. So here we can see there is a phasor difference phi between voltage and current. If the circuit will be purely resistive, then voltage and current will be in the same phase. If circuit is purely inductive, then voltage will lead the current by 90 degree. But it is combination of R and L, therefore voltage is leading the current by some angle phi. So we can write here V equal to Vm sine omega t as it is given, and I will be equal to Im sine omega t minus phi, because current is lagging the voltage by some angle phi. Yeah. Now what will be the power? So power will be P equal to what? V into I. So we can write here Vm sine omega t Im sine omega t minus phi. So basically we can write Vm Im sine omega t and sine omega t minus phi. Clear? Now here we can apply a formula Vm Im by 2 and multiply this expression with 2 sine omega t minus phi. Here you can write cos a minus b minus cos a plus b at the place of this. So what will be the value? Vm Im by 2 in bracket you can write cos a minus b, so it will become cos phi minus cos a plus b. So this will be the expression. So the power have two components, Vm Im by 2 cos phi minus Vm Im by 2 cos 2 omega t minus phi. So basically this component will become 0. Average value will become 0. This component will become 0. So overall P average will be equal to Vm Im by 2 cos phi. So at the place of Vm Im by 2 we can write Vm by root 2 Im by root 2 into cos phi. So it will become Vrms Irms cos phi. This will be the P average power for series RL circuit. Clear? Now if I will draw the waveform, the wave diagram for the voltage and current and power, so what I will get, look here, this was the voltage, this was the voltage. Now what is current? Current is lagging the voltage by some angle phi. Let me take this angle as a phi angle. Basically it means current will start, voltage is starting at 0 but current will start at some delay. So this is called the lagging of angle phi. Suppose this angle is phi, so current will start from here. So from here it will go in this pattern, right? So at the joining point, let me proceed these points further. Now what will the power for this instant? Both current here, this will be the waveform. So here voltage is 0, so power will also be 0. Between these two instant, I should mention here 1 2 3 4 5 6 7 and 8. For instant 1 and 2, here you can see that current is negative but voltage is positive, so power will be negative, and at instant 2 current is getting 0, therefore power will also be 0. So for this period we are getting only this power. Now between 2 and 3 both current and voltage are positive. Between 3 and 4 again both current and voltage are positive, but at 4 voltage is getting 0, therefore power will also get 0 because power is multiplication of voltage and current. Now what will happen for this instant 4 and 5? Between 4 and 5 what will happen? Voltage is negative and current is positive, so multiplication will be negative, and at instant 5 current is getting 0, so power will also become 0. Now between instant 5 6 and 6 7 both current and voltage are negative, so their multiplication will be positive. At 7 voltage is getting 0, therefore power will also get 0. And between this instant 7 to 8, So this will be the scenario of power. This is current and this will be the power. So here you can see initially power was negative, then power is positive, then again power is negative, and again power is positive. So in RL circuit, power is only consumed by R. L will not consume any power. Clear? So this was the concept of series RL circuit. Now let us start with power triangle. Power triangle for RL series circuit. So what is this concept? Basically what we will do, voltage is this and current is lagging by some angle phi, as we have already discussed. So here current can be divided in two components like this, and one component will be here. So this component will be I cos phi and this component will be I sin phi. Here, so basically if you will multiply all these, so here you can draw it here. This will be the I sin phi. On multiplying this triangle with voltage, what you will get, here you will get Vi sin phi. Here you will get, sorry, here you will get Vi cos phi, and here Vi sin phi. So it will be the total V into I. So basically what is Vi cos phi? Vi cos phi is equal to P. It is termed as active power. Vi sin phi is termed as Q and the name is reactive power. And Vi is basically S. It is termed as apparent power. Apparent power. So basically from this triangle you can write like this. So S will be equal to P square plus Q square, or S will be equal to the phasor sum of these two quantities. Here, so this was the power triangle. Let's solve a question, a simple question. First of all, let us discuss the power factor. Power factor. Power factor is what? It is defined as cos phi. Power factor is something like this angle is called as power factor, the angle between voltage and current. So this is the angle cos phi. The cos of this angle is called as power factor. Or power factor having one other formula is like R upon Z. So basically power factor tells you how much your circuit is resistive. How much your circuit is resistive? If circuit is only resistive, it means Z will be equal to R, then cos phi will be equal to what? R upon R equal to 1. So for resistive networks, power factor is always unity. Now power factor tell you one more thing, how much your circuit is efficient. If circuit it is written that if it is written that circuit is consuming 80% of power. That means power factor is 0.8. It means how much circuit is consuming active power. It also termed as power factor. So this was the theory concept of series RL circuit. Now we will do one or more numerical problems to get more detail about RL series circuit. So first question is that we are having a coil. We are having a coil, and it is given that resistance is equal to 7 ohm and inductance L is equal to 3.18 sorry 31.8 millihenry. It is given here, resistance is given, inductance is given. Now it is connected across voltage equal to 230 volt and frequency is 50 hertz. Now what we have to calculate? We have to calculate, first part is current, second part is phase angle, third part is power factor, and D part is what? Power consumed. Clear? All these four parameters we have to calculate. So first of all, what I will do, L is given, so I will calculate XL. XL is equal to what? 2 pi FL, because it is omega L. So what will be the value of XL? 2 into pi into frequency is given 50 hertz and L is given 31.8 millihenry. So the value of XL will be equal to 10 ohm. Here the L is given in Henry and XL is given in ohm because it is inductive reactance. Here, so what will the value of Z? Z will be equal to under root R square plus XL square. So R is what? 7 square plus 10 square. So it will become 12.2 ohm. This is the Z. First question is done. Sorry. Now we have to calculate the first question. So current will be equal to what? V by Z. So what is V? 230 volt. And what is Z? 12.2. So it will become 18.85 ampere. Clear? Second question is phase angle. So we have already know that this will be the triangle. If I will talk about impedance triangle, then it will be R, it will be XL, and it will be Z, and here the angle will be phi. So tan phi will be equal to XL by R, then phi will be equal to tan inverse XL by R. We know the value of XL and R. So what is the value of XL? Tan inverse XL is equal to 10. We have already calculated, and R is already given. R is 7. So it will become 55.0 degree. It will be lagging or leading, as we have already discussed that in RL series circuit the angle will be lagging nature. Current will lag the voltage, so it will be lagging. Now power factor, as we have discussed, cos phi will be equal to R by Z. So what is R? R is 7. What is Z? Z is 12.2. So it will be equal to 0.573, or you can calculate it like cos angle is already obtained 55 degree. So here also you will get the same value 0.573, and power factor will be lagging here. Next is power consumed. So what will be the power consumed? P equal to Vi cos phi. This is only the power that will get consumed. So what is voltage? 230 volt. What is current? We have calculated current. Where is current? This is current, 18.85 ampere. 18.85 ampere. And what is power factor? 0.573. So you will get 2484.24 watt. This will be the power which will get consumed in the circuit. Clear? So this is the concept of series RL circuit. Clear? Let's do one more question. So what will be the concept? We are having a circuit. And here AC supply is connected. This is R, this is L. Okay, R is given 75 ohm and it is given 318 millihenry. Now 50 hertz supply is already given. The voltage across resistor is given VR. VR is given 150 volt. Clear? What we have to calculate? We have to calculate the supply voltage. And phase angle. These two values we have to calculate. So when VR is given, as we know that in series circuit the current will be same. So VR will be equal to what? I into R. R is given, so I will be equal to VR upon R. VR is given 150 volt, R is given 75 ohm. So current will be equal to 2 ampere. This is the value of current that will flow in the circuit. Clear? Here I is equal to 2 ampere. So L is given. We have to find first of all XL. So what will be the value of XL? 2 pi f into L. So put the value 2 into pi into f is 50 and L is 318 millihenry. 318 into 10 raised to power minus 3. So it will become 100 ohms. This is the value of XL. So what will be the value of VL? As we have already calculated the current, so I into XL. What is I? 2 ampere. And what is XL? XL is 100 ohm. So it will become 200 volts. This is the value of VL. Clear? Now we are having the value of VR and we are having the value of VL. So what will be the voltage of supply? VR square plus VL square. So it will become 150 square plus 200 square. So finally the V supply voltage, V will be equal to 250 volts. This is the supply voltage. Clear? Now we have to find the phase angle. So phase angle phi will be equal to tan inverse XL upon R. So what is the value of XL? Tan inverse XL is equal to, we have calculated XL. XL is this 100 ohm. So 100 upon R is 75. So it will become tan inverse 4 by 3. So the value will be 53.06 degree. And what will be the nature? As it is RL series circuit, so it will be lagging nature. Clear? So it is all about the series RL circuit. In next lecture we will start series RC circuit, and if you want to know more about circuit behavior when circuit is connected with only R, only L and only C, you can refer my previous videos and you can get more fundamental knowledge about basic electrical engineering. Thank you.